Alright, this is Eric Olson's video worksheet number 1, going through number 11, which is like a 3-part question, 47 through 49. Alright, so first you've got these two concentric spherical hollow shells. For A, you can see that there's different radiuses, A through D, depicting like different spots along the shell. Inner shell's got a charge of plus 2q, outer's got a plus 4. So let's start off by finding the E field at each radius, so less than A, so that's inside the ring right here. The charge enclosed for that area is 0, because it's inside the first spherical shell, so the E field is total at 0. Alright, so in between point A and B is like inside the first shell, so it's the same issue. So I figured I'd draw a little graph thing from our notes. So if you look at this, like if this is a spherical shell of any charge, while you're still inside of it, all the way to like the very edge of it, the electrical field is 0 until right when you get outside, and then it exponentially decays based on distance further away. So yeah, that basically just explains why it's an electrical field inside of the shell is 0 and all that area. Alright, so now moving on to in between the outside of the first and the inside of the second. So, using Gauss's law, you've got the integral of the electrical field times the derivative of the area equals Q enclosed over epsilon naught. So, since the electrical field doesn't depend on area in this case, because it's just a static shape, it's just E times A equals Q over E. So we know that the surface area of a sphere is 4 pi r squared. We know that the Q in this time is 2Q because that's what we were given right up there. And that totals, if you move everything over, so electrical field equals Q over 2 pi r squared epsilon naught. Because it's positive, it's radiating outward uniformly from this radius. So now moving on in between the sides of like the last ring, so it's the same problem as before. I just talked about it, but its electrical field is going to be 0 as well. So then getting outside of the sphere, at this point, you just take the sum of the charges. So same formula, E times A equals Q over epsilon naught. So if you move that over, so 6Q is your total because it's 4 and a 2Q up earlier. And if you take that out over it, so it's E equals 3Q over 2 pi r squared epsilon naught, and it's radiating outward as well. Alright, so then now the part B was to calculate the charges at various lengths. So on the inside of the inner surface, it's still 0 because it's inside the shell. When you get to like radius B, like right outside the first ring, the charge is 2Q, which is like the charge that you were given. And then the next spot was C, which is the inner shell of the ring. That's negative 2Q, and then the last one was on the right outside, so then you just sum up the charges and it's 6Q. So then the next two parts were all they did was they changed the charges on part of the shells. So the outer shell has charge negative 2Q now instead of plus 4. So the electrical field for the first two are going to be unchanged. They didn't depend on it. Also the fourth one. But if you look at the third one, which is the space right here in between the two shells, that's going to be actually the same because it's still a positive 2Q. That's the charge that's important from the first shell, and it's radiating outward. So then 4 is unchanged as well because you're still inside of one of the shells at that point. And then once you get outside the shell, the only thing that's different is that because it's a negative 2Q on the outer shell and a plus 2 on the inner shell, that basically means that since the charges cancel, the Q goes to 0, so the electrical field is 0. So moving on to the second part, the first section was unchanged because you're still inside the shell. Part 2 was unchanged because it's still plus 2Q. Part 3 was unchanged because it's on the outside of the first shell, and that's still minus 2Q. But like I said, since the charge is 0, the Q will be 0 in the end. Alright, so then this time all they did was they changed the charge to negative 4Q. So the first two are unchanged as well because they don't depend on it. Also the fourth one, they don't depend on it. Let me just go back real quick. You can just look here, because they're inside, that's inside the area of the shell, and that's not outside of the area of the shell, they add up to 0. Or electrical field adds to 0. Alright, so number 3, this time it's actually the same because we're still dealing with the charge from the first ring. So that's going to be E equals Q over 2 pi r squared epsilon naught outward. just like we had last time. So you have 4 doesn't change, and then this last one, because the -2 overrides the +2 charge, or -4 charge overrides the -2. Said that wrong. So the outer charge of -4 overrides the inner charge of +2, so you get a negative. So what that means is it doesn't change any of the data, it just means that it's a negative, so that means that the field will be flowing inward at that point. So for part B, the first one's unchanged again because once again you're inside of it. That one's not changed because they don't change the charge of the outer shell, or the inner shell, I'm saying. That one's unchanged because they also didn't change the inner shell. But this one, because it's you sum the charges, and 2 plus -4 is -2. So that's the final charge on the outside, like right here. Oh, right about there. Alright, all done.